When we're dealing with radicals, especially division, we need to make sure the following things are true. We need the radicand, the thing inside, to be as small as possible. We need to perform every operation possible. Eliminating fractions in radicand, so we cannot have fractions in our radical. And eliminating radicals in the denominator of a fraction, we can't have a radical in our denominator. So we can't have a fraction in it, or it can't be at the bottom of a fraction. So here are our steps. Simplify the fraction. So let's look at letter A and do this. Simplify it, we can do that, divide them both by 2. Rewrite the fraction using the quotient property, split them up. Simplify A or B if possible, should be A and or B. Root 3 we can't do anything with. Root 4 is just 2. And then if a radical still exists in the denominator, which that's not the case, multiply the numerator and denominator by that radical. So we don't have to do that last step. So that's it. Letter B. We simplify it. 3 goes into both of those numbers. Then we split it up using the quotient property. We simplify. Square root of 5 can't be simplified. There's no pairs. Square root of 9. Got a pair of 3's. It's just 3. We also know the square root of 9 is 3, so we don't have to write this little factor tree out. So it's root 5 over 3. We can have the radical in the numerator, but not the denominator. Letter C. We can divide those both by 2. We split them up. Simplify. 24 is 4 and 6. 2 and 2, and 2 and 2. So we have a pair of 2's. We bring that out. But we don't have a pair for the 2 or the 3, so they stay inside. And we multiply those two together. We have 2 root 6 for our numerator. Our denominator, a little bit easier. Pair of 5's, nothing left over, so it's just over 5. All right, more problems. Letter A. We need to simplify if we can. 7 over 2, can't do that. So we split it up. Now we have root 7 over root 2. We can't break down either one of them. 7 is just as prime, and so is 2. So now we need to multiply by the denominator. So root 2 over root 2. Root 2 over root 2 is 1. And if we multiply by 1, we don't change anything, but it looks different. So we multiply the root 7 times root 2 gives us root 14. Root 2 times root 2 is root 4, which is, now we can't simplify the 14 and the 2 because the 14's out or inside the radical and the 2 is outside the radical. So that's as far as we can go. Letter B, we simplify first, divide each by 2, split them up. Again, we don't have perfect squares. I can't take the square root of 5, I can't take the square root of 3, and there's no pairs in there. So I need to multiply by the denominator. So in the numerator, I get root 15. Denominator, I get root 25, or just 5. And again, we can't do anything with the 15 and the 5 because the 15 is inside the radical, the 5 is not. These ones are already split up for us, but we can still simplify them. We can divide them both by 5. Actually, we can do them both by 15. So 15 divided by 15 is 1. 45 divided by 15 is 3. Square root of 1 is just 1. And now we have the square root of 3. So we need to multiply by root 3 over root 3. So root 3 times root 3 is just 3, or root 9. And up top we have root 3 times 1 is just root 3. Letter D, now we have numbers out front. Doesn't change what we do. So 2 over 5. And then 3 and 6, we can divide them both by 3. So square root of 1 is 1. 2 times 1 is 2. But we have a radical in our denominator. We have that square root of 2, and we don't want that in our denominator. So we multiply by the radical of our denominator, just like step 4 says. So when we do that, in the numerator we get 2 root 2. In the denominator we get 5 root 4. We can't break down 2, we can break down 4 into 2 with no leftovers. So 5 times 2 is 10. Now we can still simplify the 2 over 10. So we divide them both by 2. We get 1 root 2 over 5, or just root 2 5. Letter E is the same thing. We can take the square root of 4, so we'll do that. Now they're already split up, so we need to multiply by the root 5 in their denominator. In the numerator, I should say. So in the numerator we get 2 root 5. In the denominator we get 4 root 25, which is 4 times 5. So 20, 2 root 5. And we look at the 2 and the 20, we can divide them both by 2. So I get 1 root 5 over 10. And I can't do anything with the 5 and the 10 because the 5 is inside the radical, the 10 is not. It's outside. So again, we can't do anything with numbers unless they're both inside or both outside. And that's dividing radicals.